Chapter 5, Force. This lecture will help you understand friction. Surfaces in contact are often under compression. Each surface pushes against the other. The outward push of each object is called the normal force. The ground exerts a normal force exerted upwards and perpendicular to the surface. When an object lies on a table or on the ground, the table or ground must exert an upward force on it, otherwise gravity would accelerate it downwards. This force is called the normal force. In this particular case, the normal force is equal to the mass times the acceleration of gravity. Since the net force is zero, the acceleration must also be zero. The normal force is always perpendicular to the surface on which the objects rest. The normal force is not always opposite the direction of the force of gravity. The normal force of the mass sitting on the ramp is perpendicular to the surface of the ramp. Normal means perpendicular. A normal force is always perpendicular to the contact surface. For example, if a flower pot is sitting on an incline, N is not vertical. It is at a right angle to the incline. Also, in this case, mg is greater than N. Friction is a force that resists motion when two objects are in contact. There are four main types of friction. Sliding friction, also called kinetic friction. Examples are ice skating and dragging a box across the floor. Rolling friction, such as seen as a bowling ball or a tire. Fluid friction includes air or liquids. Friction due to air resistance, such as what is felt when you stick your hand outside of a moving car. Static friction. Static friction is the initial friction experienced when moving an object. Objects do not instantaneously move when you push them. You have to overcome static friction. Friction resists motion of objects in contact with each other. If you look at the surfaces of all objects, there are tiny bumps and ridges. Those microscopic peaks and valleys catch on one another when the two objects moving past each other are in contact. Surfaces can be polished to reduce friction, but at some level, these little bumps and ridges are always present. Friction can be reduced, but it can never be eliminated entirely. Friction increases as the applied force between the surfaces increases. Let us first look at static friction. We define friction as the force that resists motion, but in the static case, the object is not moving. Static friction opposes the start of motion. Static friction must always provide just enough force to keep an object at rest. If the two forces were not exactly equal, the object would start to move. The figure shows all of the forces acting on the trash can. A force is applied to the right. The static frictional force is equal, but in the opposite direction as the applied force. The trash can does not move to the right or left. There are two more forces acting on the can: gravity pulling down and the normal force pointing up. These two must also be balanced, or else the trash can would rise up from the ground and plow into the earth. Static friction can be defined in terms of the normal force. It is less than or equal to the normal force, N, times the coefficient of static friction, which is given the Greek letter mu with the subscript s. The coefficient of friction describes how rough or smooth two surfaces are when they are in contact with each other. A higher coefficient indicates the two rough surfaces, whereas a lower number indicates two smooth surfaces. In this case, the normal force is equal to the weight of the object. This is not always true, so be careful when defining the normal force. The graph shows the magnitude of the static friction as a function of the applied force F. The static friction is always equal to the applied force. Static friction opposes the direction of an object would move if it were allowed to move. We know from experience that if we push an object just a little harder, the trash can will start to move. We have overcome the static friction. The maximum static friction that can be produced is equal to the coefficient of static friction times the normal force. Any force that exceeds the maximum static frictional force will move. We define F sub s, comma, max as the maximum allowed force that keeps an object from moving. Kinetic friction is parallel to a surface and always opposes the direction of motion. In the diagram, the motion is to the right. Kinetic friction, indicated by the lowercase f with the subscript k, is to the left. Friction is independent of the area of contact. It only depends on the nature of the materials in contact and the forces pressing them together. In the case of kinetic friction, the object is in motion. The force of kinetic friction is equal to the coefficient of kinetic friction times the normal force. The object is now in motion. Experience should tell you that it is harder to get something to start moving than to keep it moving. The coefficient of kinetic friction must always be less than the coefficient of static friction, as is shown in the graph. Kinetic friction force opposes the direction an object is moving. When the object is moving, we have three possible types of motion. If the force of kinetic friction is exactly equal to the applied force, then there is no net force acting on the object and it must move at constant velocity. If an applied force is greater than the force of kinetic friction, then there is a net force acting on an object and it will accelerate. If the applied force is less than the force of kinetic friction, then the object will decelerate and eventually stop moving. We see friction as we slide a book across a table. It begins to move as our hand is in contact and pushes the book, overcoming static friction. A little bit more of a push keeps the book moving. Here the applied force is greater than kinetic friction and the book accelerates. Once your hand releases from the book, the kinetic friction opposes the motion and the book eventually slides to a stop. Table 5.1 in your book gives the coefficient of static friction and kinetic friction for various substances.